Welcome friends. Again we discuss several variable calculus. In the last session we discussed the limit of the function and example on it. And today we have to discuss the continuity of the function of two variables. So today's our topic is continuity of function of two variable. If you try to remember, we also discussed the continuity of the function of one variable. Just we try to revise this. So what is continuity for one variable? For one variable. So what we have to take, suppose f is any function, real valued function defined on the domain D subset of R. Then we say that the function f is continuous at x tends to a. When it is limit x tends to a, f of x is equal to f of a. That is limit we can find by using the direct substitution method. That is what we can say, that the function is continuous if what, limit x tends to a, f of x is equal to a. How we check the continuity? What are the steps to check? So what is first find, what you have to do, find limit x tends to a, f of x, and then what we have to find, secondly we have to find f of a, and third we have to check x tends to a, f of x is equal to f of a. What is the geometrical meaning? Geometrical meaning of the continuity, that is, there is no break for the, not a break or cut to the curve. So how we say that the function is continuous? If the function or the curve is not cut or it has no break, then we say that the function is continuous. Just now we have to, same concept we have to discuss for function of two variable. So how we write? Suppose, so definition, how we write this? Suppose f is a function of two variable defined on the domain D subset of R square. Then we say that the function f of xy is continuous at AB in D if what we can, when, how, if limit of xy tends to AB, f of xy is equal to what? F of AB. So what we are taken, f is any function defined in the domain D subset of R square, and then we say that the function f of xy is continuous at AB if the limit of f of xy is equal to the value f of AB. If you write the precise definition, that is, if you write the precise, or we can say that the epsilon delta definition. How we write epsilon delta definition? That is, for a given epsilon greater than 0, there is a corresponding delta greater than 0 such that how it is, such that all xy is in D, and what we can say that, and square root of x minus a square plus y minus b square is less than delta, then what we can say, then mod of f of xy minus, in the limit definition there is L, but what is here, it should be f of AB is less than epsilon, so what is the change, what is the difference in the limit and the continuity? Here is a, in the limit definition, here is a L, okay, but what is the change, one more change, here is what, this is not a deleted neighborhood, this is the neighborhood. That means this neighborhood can contain a point AB, but in the definition, in the limit definition, here is a deleted neighborhood, remaining all the same. Okay. Note, if f is continuous at all point AB in D, then f is continuous on AB, on domain D. That is, if it is continuous at all point in D, then we say that f is continuous on the domain D. Second note, the geometrical meaning of continuity is if xy changes by a small amount, then f of xy changes by a small amount. That is, if xy changes by a small amount, then we can say that f of xy is also changes by a small amount. That is what, that is the graph, or we can say that the surface, that is a graph of function f has not whole or, okay, for the curve it is not break or it is cut, but here is what, not a hole, here is a surface, therefore this surface has not a hole or it is not break into the 2 points. Okay. So what we take, what is our polynomial function? Polynomial function in 2 variable. Polynomial function in 2 variable is the sum or difference of the term. Which term, what we can say, which term it is? C x raised to m y raised to n. Also what we can write for you, a rational function function is the division of two polynomials. Division of two polynomials. Rational functions, here we can take example. Suppose f of xy is equal to x cube minus y cube upon x square plus y square. This is the rational function and it is the division of two polynomials. Similarly, here we can take example. Suppose f of xy polynomial is suppose x raised to 4 plus 4x raised to 2 y raised to 3 plus 4xy plus y raised to 3 and so on. Suppose this is the one polynomial is given. So what we see, geometrical meaning, continuous, polynomial function and rational. Now we have to see the some theorem of so algebra of continuity. Again, yesterday what we discussed or in the previous lecture, f is function, g is function defined on the domain D subset of R square, and suppose C be any real number, then what we can say that they are the two variable functions. So what we can write, f plus we know that we have all the limit of algebra of a limit of the function. Similarly, by using this we can prove the algebra of the continuity. So what we can say that limit xy tends to ab f of xy plus g of xy, what we can say that it is equal to what, f of ab plus g of ab. Similarly, you can write for difference, you can write for product, you can write for division. Division provided what, g of ab is not equal to 0. Provided g of ab is not equal to 0. So you can prove the algebra of limit. It is very simple. So by using this algebra, what we can write? We can write note number 6. That is, every polynomial function is continuous, because if we take f of xy is equal to x raised to m, g of xy is equal to y raised to n, and h of xy is equal to c, then what we are using, by using algebra, we can say that this is the product, this product is continuous, therefore their sum is continuous, difference is continuous, and that means what, we can say that this polynomial function is always continuous at any point, and we can find the value of limit by direct substitution. Okay, so put the value directly, you will get the answer. 6th number, a rational function. Again, what, rational function is the division of the polynomial, and what we can say that this function is not defined at the denominator, and therefore where denominator is 0, and therefore we can say that the rational function is continuous on domain D of the function. Okay, so what we can say that polynomial function is always continuous and rational function is continuous in the domain. And what is domain? Domain is the set of all points where the function is defined. Okay, so this is just some theory of the continuity. So we will go for the problem. So we will discuss some examples on the continuity. So our first example. So we solve first example. What is our first example? Evaluate the limit limit xy tends to 1 to x square y cube minus x cube y square plus 3x plus 2y. So what is it? It is our polynomial function. So what we can say, let f of xy is equal to x square y cube minus x cube y square plus 3x plus 2y. So what we say that it is polynomial function, therefore it is defined, or we can say that it is continuous at every point. Therefore, as f of xy is polynomial function, as f of xy is polynomial function, f of xy is continuous everywhere on R square, and we find the value by direct substitution, So limit xy tends to 1 to f of xy, it is equal to what? 1 square into 2 cube minus 1 cube into 2 square plus 3 into what we can say? 3 into 1 plus 2 into 2, and what is it? 1 square 1, 2 cube 8 minus 4 plus 3 plus 4, this should get cancelled and it is equal to 11. So value of limit is 11. So it is polynomial, therefore it is continuous everywhere in the domain D. Okay. So how we solve the second one? Example second, solution second. How we solve? So given, what is given? F of xy is equal to x square minus y square upon x square plus y square. What is it? Is a rational function, and therefore what we can say that, therefore f of xy is continuous at every point in domain D. And how we find the domain? The domain is the set of all xy where the function, which function? F of xy is defined. From the function from f of xy, we can say f of xy is not defined. Where it is not defined? Defined if xy is equal to 0, 0. So what is the domain? Domain is equal to what? All xy where xy is not equal to 0, 0. Okay. Therefore what we can say that the f of xy is continuous except xy is equal to 0, 0. Therefore it is continuous for all point except 0, 0 or origin. Okay. So first two examples are completed. What is third example? Third example is again a similar second example, but what we have given, it is function value at 0, 0 is also given. What we see in the second, this function is not defined at 0, 0, therefore we can say that it is discontinuous at point 0, 0. But here what is given? We have given third example we have what we say that it is rational function, therefore it is continuous everywhere in the domain, and therefore what we can say that we have g of xy is continuous for all xy is not equal to 0 0. Why it is? As it is a rational function. It is a rational function. So now what is remaining? It is defined for, it is continuous for all point where not equal to 0. But what now we have to check it is for, now we check for xy is equal to 0 0. So use the definition of continuity. What is given? We have g of 0 0, it is equal to 0. Say this is equation number 1. Now what we have to find? We have to find the limit xy tends to 0 0 f of xy, or we have g of xy, it is equal to what? Limit xy tends to 0 0. What we can say? It is equal to what? X square minus y square upon x square plus y square. Okay, so we have to find the limit. How we find? The previous lecture we see it is homogeneous, so you can take a path limit, take a limit along a path y is equal to mx. So it is homogeneous of degree 2, therefore we can find the limit along the path y is equal to f of x. So what we can write here? Limit, what we can write? X mx it tends to 0 0. What we can write here? X square m square x square upon x square plus m square y square. And what we can say that this limit, it is x tends to 0, both are x, so it is x tends to 0, x square take common, so 1 minus m square upon x square again common, 1 plus m square. And what is this point get cancelled, and here is not a x remaining, so it is 1 minus m square upon 1 plus m square. So what we can say that thus the value of limit is depends on m. Therefore what we can say that therefore limit f of x limit g of xy, or limit g of xy as xy tends to 0 0 is not exist. So we have a value g of 0 0, but this limit is not exist, and therefore we can say that the function, or what we can say that the function is not continuous at 0 0. Therefore the function g of xy is not continuous at 0 0. So what we can say that not continuous or discontinuous we can write. Okay, so what are the steps? What are the steps to find the, or to show the continuity? First, find f of AB. Then second, what we have to find limit xy tends to AB f of xy. And then third, what we have to check, it limit is equal or not. All xy tends to AB, it is f of xy is equal to what? F of AB. So what we did in this case, we find this function value at 0 0, then we try to find the second one, but this is not exist, therefore we can say that this function is discontinuous. Okay, if this is not exist, no need to go no need to go for the next, or it is not possible to go to the next. If this both exist, then you have to check this third step, and that is, these are the steps to check the continuity. And so Now we will solve the second last example of this. What is this example? Discuss the continuity of the function f of xy is equal to 3x square y x upon x square plus y square if xy is not equal to 0, 0 and it is equal to 0. What we say that again, it is same example like example number 3. So what we can solve? So what we can write? The function f of xy is continuous at all points in R square except xy is equal to 0, 0. Okay, as why it is? As f of xy, it is a rational function. It is a rational function, therefore it is not defined at denominator, and therefore we can say that it is not it is continuous except the denominator where it is a 0. Now we check continuity. We check continuity at 0, 0. So for this what we need? This example already we solved yesterday also or in the previous lecture. What we did here? That time we used the epsilon delta definition, and that time also I told you that is you can solve this by different methods like polar method, or you can go by the theorem, that is if one function is bounded, second is limit 0, then we can say that this function is, that means what, this product is 0. So we can solve it by we use the polar coordinates to find the limit of what? Limit of f of xy at 0, 0. So what we have to do in this method? Put x is equal to r cos theta, y is equal to r sin theta, and therefore what we can write? Therefore and what we can write? And xy tends to 0, 0 implies r tends to 0 plus. Therefore what we can write? Limit xy tends to 0, 0 f of xy is equal to limit r tends to 0 plus what we have to write? 3 into x square. X square is what? M r cos theta square into r sin theta upon r square cos square theta plus r square sin square theta. And what we can say here? Limit r tends to 0 plus, just do simplification, 3 here, r square, r is r cube cos square theta sin theta upon what? R square, just common cos square theta plus sin square theta, and then use the identity. This is what? This is nothing but our, this get cancelled, and what is remaining here? 3 cos square, 3r cos square theta sin theta upon this identity value is 1. So since cos square theta plus sin square theta is equal to 1, and then what we can say that this is equal to what? 3 into 0, it should be what? 0, and therefore what we can say that limit xy tends to 0, 0 f of xy is equal to 0, and it is equal to what? Our, this is equal to our f of 0, 0. This is equal to our f of 0, 0. Therefore f of xy is continuous at 0, 0, and therefore we can say that f of xy is continuous A on all point in R square. Okay. So similarly you can solve the so many problems. Okay. So thank you very much.